Good afternoon, everybody. Meteorologist Blake Mathews here. It is day 4 of the weather classroom. It is Monday, what I like to term Manic Monday, Houston disasters, and our vulnerabilities. Of course, we have a huge population center. 7 million people live in southeast Texas and the greater Houston area, and that makes us vulnerable because we're on a very low-lying plain, on a very tropical body of water, and those two combinations usually are not good, especially when we get to the summertime and we're dealing with tornadoes and hurricanes and flash floods. We're going to discuss all of that and a whole lot more coming up here in just a few minutes. So here's what we're going to be talking about. We're going to be looking back at past disasters here across the Houston area. Why are we so vulnerable here? And of course, tornadoes, hurricanes, and a whole lot more. So let's start off with a look at tornadoes by the month. You'll see that one of the most active, believe it or not, for tornadoes here in southeast Texas is November. We've had 89 of them since 1992. May is another very active month here across southeast Texas, but generally each month we've seen tornadoes. Now the reason why we see a spike in the spring and we see a spike in the fall is because of cold fronts and the changing seasons, as you would expect. So tornadoes are certainly no stranger to our area. In fact, we've had 371 EF0 tornadoes since 1992, 122 EF1 tornadoes, 28 EF2, 5 EF3, and of course you look ahead towards the EF4 and the EF5. These are the devastating tornadoes that cause catastrophic damage. We've only seen one EF4 tornado ever hit southeast Texas. That was back in November of 1992 out in the Sterling Green neighborhood in Channelview, rated F4 at the time, approaching 1 mile wide. 200 homes destroyed, and 1,000 of those were seriously damaged. That was a very nasty outbreak here across the Houston area. In fact, in Harris County at one point had 3 tornadoes on the ground at the same time. So that is something that we don't see a whole lot of, and here's the reason why. Here's the setup, the United States. There we are here in the Houston area. Of course, we all know the Rocky Mountains. We all like to go skiing out there in Colorado, Utah, and into New Mexico. But those Rockies are kind of home to all the cool, dry air out there to the west. Out ahead of it, we've got a strong flow coming in out of the Gulf of Mexico. This provides the warm, humid, gross days here across southeast Texas. Well, coming off of the Rockies, you've got that cool, dry air. And look what happens. You've got the warm, moist air coming in from the south, the dry, cool air coming in off the mountains and dropping down. And the air masses that collide, look where they collide. They collide right over Kansas and Oklahoma. Anybody know what that's called? Yeah, Tornado Alley, and that is where we see some of the strongest tornadoes in the country, and it's because of that mixing air mass. Now, out ahead of the Rockies, this is a prime location for areas of low pressure to develop. We call that cyclogenesis. Now, when you're dealing with a cyclone, normally you get a spaghetti of fronts that develop with that. So, as the area of low pressure forms, you get wind coming in on the backside of it, around from the north. Out ahead of it, you've got winds coming in from the south, and you see already generally you've got a circulation in the atmosphere with those colliding winds. So you've got cool air on the backside that produces a cold front. Out ahead of it, you've got a warm front that brings the warm air north out of the Gulf of Mexico, and then this little yellow line right here, it's very conspicuous looking. It's what we call a dry line, and that is normally where you see lines of very nasty and strong thunderstorms begin to develop. So the reason why we have tornadoes across the country in general is because we're a perfect location, one of the most perfect locations on the entire globe for tornadic formation. Now, you say, okay, well, that's Kansas and Oklahoma. What does that have to do with Houston? Well, the reason why we are talking about this is because every once in a while, you get these areas of low pressure to dip a little bit further to the south. And this is what we saw happen in 1992 when you get all of the dynamics in the atmosphere lining up very close to home. And this is when we can get some nasty tornadoes. Now, the reason why that we do not see the very strong, intense, mile-wide tornadoes that you see in Oklahoma or in Kansas or even sometimes out towards Alabama and Tennessee is because we have a very maritime environment. Very difficult to get strong tornadoes here in southeast Southeast Texas because you have to have a lot of cool air aloft and you have to have a lot of strong wind shear. Those two things oftentimes do not line up here in Southeast Texas. It's marginal at best, which is why we have a lot of EF0 and EF1 tornadoes. So we have a ton of very weak tornadoes that drop down and they hit a house or two and then they're gone. Normally, by the time a tornado warning is issued, those tornadoes have long dissipated. We don't have the long lead times that they have up north where those tornadoes can be on the ground for 15, 20, 25 miles at a time. Now, this is a picture from Space City Weather from Channel View in 1992, and you can see this is from the Sterling Green neighborhood, some of the hardest hit streets, Moorside Drive and Grassington. Grassington and Moorside was the intersection that really got decimated in the Sterling Green neighborhood. You could see a lot of the roofs were pulled off, and this is not even some of the worst damage that we've seen. Here's another look. This is, if you look carefully at the street sign, that's Moorside and Grassington, and you can see all of the homes just totally decimated here. Cars that were flipped over, and again, this is thanks in part to NOAA and Space City Weather for providing this image, but you can see just how nasty that is. Now I'm going to take this intersection, Moorside and Grassington, and let's take a look at it today. And you can see all the homes have been rebuilt, but there's that street sign that we circled in the last image. In fact, I'll go back and show you that one more time. And there it is. There's that same street sign. You can see all the homes that were on that particular intersection were just totally decimated there in Channel View. And again, this is the strongest tornado ever known to hit Southeast Texas. So it can happen, but it's pretty rare. Here's another satellite image, by the way. And if you look at Google Maps of the Sterling Green neighborhood, if you look carefully and know what you're looking for, you can spot, even still to this day, some tornado damage. Look at the driveway right there that is still there that leads to no house, just an empty lot. So while most of the homes in Southeast Harris County have been rebuilt, every once in a while you can still spot some tornado damage. Not sure if this is tornado damage or not. I just thought this was interesting. You've got one driveway there and another driveway here with a big space in between. And that may signal where a couple of houses used to be. Of course, the land has been repurposed and one house now sits there. But again, you can see pretty clearly that a pretty nasty tornado went through that area. Now, here is more of what we see in Southeast Texas. This is from Eagle Lake on southwest side of town. And you can see that we're dealing with an EF1, maybe EF2 tornado. You get this stovepipe looking type twister. And these are the kind that don't last long in a very maritime looking tornado. So these are the kind that are generally on the ground only for about 3 or 4 minutes before they begin to dissipate. And oftentimes they are responsible for cosmetic damage. These are not the type of tornadoes that would totally remove your house from its foundation. The other vulnerability that we have and can also produce lots of tornadoes is hurricanes, and the most prime time for Houston to be in a hurricane or tropical storm is generally right around mid-August all the way through the end of September. Can hurricanes and tropical storms hit in the early part of the season? Well, you bet they can. In fact, let's take a look here at the month of June, and these are all the June hurricanes that have hit the state of Texas dating back to the late 1800s. And you can see all the yellow lines are going to be Category 1 hurricanes, and the orange line here is going to be a major hurricane. Anybody know what the pink line is? I'll give you 3 seconds to think about it. Hurricane Audrey, back in 1957. So you can see that even though technically that was a southwest Louisiana landfall, it certainly got very, very close, and that was a late June hurricane. So they can happen in Southeast Texas, but the prime time for hurricanes to hit Texas is August and September. And really, the end of September is a pretty hard cutoff date. And the reason why? Anybody? Anybody? Cold fronts. Once the cold fronts begin to sweep off the coast, that acts as a big broom to pick up any tropical storm or hurricane and to sling it on off to the east. So our hurricane season here in Southeast Texas pretty much shuts down pretty hard by the end of September. We've only had one, I think maybe 2 hurricanes ever hit Texas after October 1st. The last hurricane to hit in the month of October actually did not happen all that long ago. In fact, some of you may remember October 1989 when Hurricane Jerry actually hit Galveston as a Category 1 hurricane with winds of about 80 miles an hour. We had winds of 50, 60 miles an hour inside Harris County. Jerry was a very small hurricane, and it formed very close to shore, kind of wiggled around, and then came right up through Galveston County and up into Liberty County. So they can happen, but the prime season, of course, is going to be right in the middle of August. Speaking of August, this is a hurricane that many longtime Houstonians will remember very well. Hurricane Alicia, Category 3, winds coming in at about 115 miles per hour. The Coast Guard cutter Buttonwood, the Buttonwood that was moored on the west end of Galveston Island, had a wind gust of 126 miles per hour. That is the highest recorded gust that I could find from Hurricane Alicia. But Hurricane Alicia will long be remembered for the amount of tree and glass damage it did inside the city of Houston. So there's its track right there, developing off an old cold front that stalled off the coast in the Gulf of Mexico and developed very rapidly within 48 to 72 hours, going from a mere area of disturbed weather all the way up to a low-end Category 3 hurricane, making landfall there on the west end of Galveston Island as a Category 3 hurricane, and pushing right through the west side, central and west side of Harris County, the eye passing right through Pinehurst into Magnolia and then on up into College Station. So again, known for its massive amount of glass damage. And what's interesting about Hurricane Alicia is that it formed in a season that only had 4 named storms. So we're talking about a season that really didn't produce much in the way of anything, but a good example and a good reminder as to why it's not the number of storms you see in a season, but it's where they hit. It only takes one to make the hurricane season very bad. In 1983 is a good example of that. What we're looking at here is the Allied Bank Center, now known as Wells Fargo Tower in downtown. It's the second tallest building in the city and in the state of Texas, and look at the amount of glass damage that particular hurricane did. And the reason why is because back then the building codes required lots of gravel on the roofs. Well, of course, that has now since been changed out. They don't use gravel on the downtown high-rises any longer, but those little pebbles were picked up in the winds over 100 miles an hour and really acted as a shooting range for the buildings in downtown. Another very famous hurricane, obviously the 1900 storm. It is still to this day the deadliest hurricane to ever hit the United States. 8,000 to 12,000 people died. Of course, back then we didn't have the satellite technology that we have today, so a lot of the researchers and meteorologists back then didn't even know the storm was out there until it was right on the shores, and by then it was too late. Another one, Indianola, back in August of 1886. This town literally wiped off the map. If you go down to central Texas into Matagorda County, to this day, that town does not exist. There is just a marker there showing where it used to be. So why was the 1900 storm and the Indianola hurricane so bad? Well, not only were they strong, but Houston and Galveston are located on what we call a concave coast. And what does that mean? Well, think of like a bathtub, the corner of a bathtub where it kind of comes together. And if you slosh water in a bathtub, guess what happens in the corner of that tub? All the water goes right up, really high, right? Well, the same thing happens on a much larger scale when you're dealing with a concave coast like Texas, and in both instances here, we had massive storm surges. It wasn't necessarily the wind that did so much damage, but the amount of water and the size of the storm surge. We saw the exact same thing happen back in September of 2008 with Hurricane Ike. Remember, Ike was only, quote unquote, a Category 2 hurricane, but had a Category 4 storm surge, and that obviously did lots of damage. You don't need a hurricane to do lots of damage. We think back to Tropical Storm Allison. This one I remember very well, dropping 40 inches of rain and causing billions of dollars in damage to the Houston area. So that's going to transition us into the next big vulnerability that we face, and that is flooding. And you could see the amount of rain that was dropped in Tropical Storm Allison, 35 inches there in northeast Harris County. But we compare that to Harvey, same color scale. Let me back this up. Come on. Come on. There we go. I want you to pay attention to the color scale. Look at the purples and the orange. And you see that bright spot right there, the green? That's 35 inches of rain, okay, from Tropical Storm Allison. Everybody see that? The green, 35 inches. Same color scale. Here's Harvey. Amazing. Amazing. So if you were here for Harvey, certainly you lived through a time period that has really never been seen before in southeast Texas, and will likely be many, many years before we see something of that magnitude again. In fact, we're talking some areas in southeast Texas picking up over 60 inches of rain. So there's Chief Meteorologist David Paul looking at a satellite image of Hurricane Harvey, at the time Category 4, just getting ready to cross over Port Aransas, what we call Port A, to the north of Corpus Christi. And this was one of the computer models that we were looking at. If you look at up here at the maximum, you'll notice it says 50.3 inches. And at the time, David and I looked at each other and said, no way. There's no way. It's never happened before. There's got to be some kind of error in the computer model here. It was an error. It was 10 inches too low, which is mind-boggling to say the least. But this is the kind of data that we were looking at. And what we see oftentimes behind the camera, we can't come out and tell you because it would scare the dickens out of you. And our goal is to stress calm and be collective about the whole thing. But when every single computer model that you're looking at is showing 25, 30, 35, 40, 50, 60 inches of rain, it's really, really hard to wrap your mind around. And the reason why is because, folks, we know that we've got a problem here in southeast Texas. Flooding is a huge deal, always has been. In fact, back in 1836, when the city of Houston was founded by the Allen brothers, a couple of New York brothers came here, they knew right away that we had a problem. So what they do, they put an article in the New York Times and said, come down to southeast Texas and see our beautiful spring water. Well, it wasn't waterfalls and Cancun type water. We're talking about a lot of flooding. It rains here, folks. It rains a lot. And that rain can cause big problems. We've got, if you look carefully, the bright blue line here. This is the Trinity River. We've got the San Jacinto River that flows down through southeast Texas. We've got the Brazos River that flows down. And then we've got the Colorado River, which flows down through Colorado County, Wharton County, and into Matagorda County. And by the way, we have a special viewer, Wendy Williams, and the kiddos. Hello. Thanks for watching out in Katy. We know you're watching right now and hope you're learning a little something. Glad you're with us this afternoon. All right. So it rains a lot here, and not only do we deal with a huge population that's sitting on a very low piece of land that's only generally 40 to 50 feet above sea level, but we're also sitting on an area of clay. And clay does not allow water to percolate very easily, and especially when you're getting rainfall rates, especially in some of these hurricanes and tropical storms of 6, 7, 8, 10 inches of rain per hour, which is just mind-boggling to the rest of the country, you can overwhelm these rivers very, very quickly. Well, guess where the rivers also feed into? Look at the fingers stretching through Harris County. Those are bayous, and those bayous, as we know, Buffalo Bayou, Greens Bayou, Sims Bayou, out there towards White Oak Bayou. All of these can get overwhelmed very, very quickly, especially many of them are lined with concrete. And of course, concrete doesn't absorb water very well, and they can rise very, very rapidly. In fact, many of these creeks and bayous are what we call flashy. Well, they're not flashy because they're sexy to look at. They're flashy because, well, they flash flood very, very quickly. And when you can get, we're talking about rain rates of 3, 4, 5, 6, 7, 8 inches of rain per hour, it can overwhelm these bayous very, very rapidly. Now, I'm going to pull my computer in here just for a second, and give me just one quick second to show you something that I think is actually kind of cool. So, not only do you have rain pouring into the bayous and into the area rivers, but think of it like a funnel, right? So we're going to open this up, turn it green, and let me open up my KML file, and we're going to talk about watersheds. Now, watersheds are kind of like a giant funnel, right? So we're going to highlight Greens Bayou. Well, there's Greens Bayou right there, but all the rain falling anywhere in this blue area runs down into those bayous. Okay, think of like the Continental Divide on a micro scale. So we know that the Continental Divide means if you pour water on this side of the Continental Divide, it's going to run down into the creeks and rivers and eventually work its way to the Atlantic Ocean. But if you pour water on this side of the Continental Divide, that water will work its way into the creeks and rivers and eventually work its way to the Pacific Ocean. So that's the continental divide, but we have the same thing that sort of happens here, but on a micro scale. And if you have water raining down here over the northeast belt, all of that water, regardless of where it falls in this blue area, is going to filter down into Green's Bayou. Here's a look at Buffalo Bayou watershed. So we know that Buffalo Bayou kind of starts on the west side of Harris County, but the watershed itself is mainly out over Channelview, Pasadena, and Baytown. We've got the Barker Reservoir, the Addicks Reservoir, Brays Bayou, Sims Bayou. That's the White Oak Bayou and Buffalo Bayou watershed on the west side. We've got West Galveston Bay, the Lower Trinity. Some of these are a little far out. Let me see where's the others? So anyway, well, there's Spring Creek. That one is very flashy as well. So not only do we live on an area that is made of clay, that doesn't allow water to percolate very well, but we live in an area that's on a tropical body of water that allows lots of thunderstorms in the afternoon, supplying that warm tropical air mass into a very hot atmosphere. Of course, we know when everything heats up, everything moves up, right, into the sky, cools, condenses, and forms showers and thunderstorms. So this is one of the main reasons, and this is our biggest vulnerability across Southeast Texas, is the flooding. And not only do we have a huge population with a huge amount of concrete, but we also have lots of creeks and bayous that kind of work their way through our area. All of them, many of them, very, very flashy. Of course, in review, we know that flashy means they flood very quickly. It means that you get a flash flood that can occur on those pretty rapidly. And of course, we have lots and lots of watersheds that form across Southeast Texas as well. So we've talked about tornadoes, and we know that tornadoes form when you get cool air, dry air, to mix with the warm, moist air. And every once in a while, when those areas of low pressure form and bring cold fronts, dry lines, and warm fronts through our area very close, we can get tornadoes. So that's one of our vulnerabilities. We also know that tropical storms and hurricanes are a vulnerability based on the fact that we're built on the coast, essentially. We're only 40 miles from the coast as the crow flies, very much within reach for hurricanes and tropical storms. We also know that those tropical storms and hurricanes, and of course our very tropical maritime environment anyway, can produce flash flooding. So those are the top three vulnerabilities of Southeast Texas, and we've showed you some very devastating examples of that as well. Now I save the best for last, because I actually am a big fan of snow and ice, and if you've lived here long enough, you know that, well, we can get that too, even though this winter has pretty much been non-existent. So let's talk about our next not so much vulnerability, because when it happens, then everything kind of shuts down and we're done for a day or two. But every once in a while, you can get a really, really big snow event to happen, and that's exactly what happened on Valentine's Day of all times in 1895. We had a high temperature that day of 21 degrees. Can you imagine? 21 degrees. Now, this was back before climate change really had the effects that it's having today. We know that we do live in a warmer world. We live in a warmer atmosphere. Not to say that this could never happen again, but it's just a little bit more difficult for something of this magnitude to take place. Now, high of 21. Then we had another reinforcing Arctic front move through just after that. And by the time we got to Valentine's Day, we had this little area of low pressure strengthen rapidly and move right towards the upper Texas coast. And on the backside of that, we had a tremendous snowstorm, really borderline blizzard, take place in Southeast Texas. Check out some of these snowfall totals. Ready for this? This is going to blow your mind if you've never seen this before. So we're talking snow that stretched all across the Southeast, but let's zoom into the Houston area. Folks, these totals are not an exaggeration. I actually never thought I would put something that large on TV, but 20 to 30 inches from downtown Houston all the way out through Beaumont and Lake Charles. In fact, there's a little spot right there on the east end of Galveston Bay, and you can look this up on Google Maps, and it's called Frozen Point. And the reason why it's called Frozen Point is on this particular event, there were 6,000 head of cattle, as it's reported, right there on the east end of Galveston Bay, and they had turned tails to the wind, and 6,000 head of cattle walked into the bay, into Galveston Bay, in an attempt to keep warm. The snow was falling rapidly, the temperatures were in the teens and 20s, and in order to stay warm, to stay alive, 6,000 head of cattle walked into Galveston Bay and drowned. And it's reported that you could have walked on their backs several hundred meters into the bay and not even gotten your feet wet. And to this day, they've marked the spot called Frozen Point. It's on, you can see this for yourself on Google Maps. And we're talking about snow drifts near Double Bayou, just east of Galveston Bay, of 6 to 8 feet of snow. I want you to think about that, 6 to 8 feet. That would shut Buffalo, New York down. And this is falling here in Chambers County. We had snow as deep as a foot, Spring, Texas, coming in at 12 to 14 inches. Sugar Land coming in, Stafford, I believe at the time, 18 inches. 20 inches in downtown Houston, 32 inches in Beaumont. So it can happen, and it nearly did happen again, by the way, on Christmas Eve and Christmas Day 2004. Many of us remember that. 13 inches falling down here in coastal Brazoria County. Some areas picking up, many areas picking up 10 inches. By far the second biggest snow event ever recorded here across the Houston area. So let's review. The reason why that we are so vulnerable here across the Houston area is because of our geography. We're located on a concave coast, and I want to show you that really quickly on a satellite image, and we'll wrap this up. So let me pull this back up. And you could see the concave coast right there. So when you have a tropical storm or a hurricane on final approach to the Texas coast, the circulation around that, as it pushes in, is pushing all that water into the Texas coast, into that concave coast. And think about it, if you splash water in a bathtub and it goes into the corner of the bathtub where it comes together, guess what happens? The water shoots up, right? Same thing happens along the northwest Gulf of Mexico on a much broader scale, and that's why we have tremendous storm surge issues here. So that's one of our big vulnerabilities when it comes to hurricanes and tropical storms. And speaking of hurricanes and tropical storms, our other vulnerability is big flooding, because again, it goes back to our geography and the type of soil that we have here, a sandy loam, it's clay not very absorbent when it comes to water, and therefore it runs off. We have a big runoff problem in southeast Texas. Couple that with a tremendous population, huge population, 7 million people living in Houston, 5.5 million of that in Harris County alone, and growing by 150,000 people a year, 1 million people per decade. You think about the amount of concrete that's being poured all over southeast Texas. Big problem. So we've talked about hurricanes, we've talked about tropical storms, we've talked tornadoes, we've talked even snow and ice, and we've talked flooding. So those are the big vulnerabilities to Houston. It's only going to get worse as the population continues to increase, the concrete that's being laid continues to increase, and we're trying to make you as aware as possible that anything here in southeast Texas is pretty much possible aside from some kind of volcanic event. No volcanoes here, but we pretty much have everything else. So I hope you learned a little something today. It's a pretty interesting topic. We've got a very violent past here across southeast Texas. Pretty interesting to read. At this time, we're going to toss it to Randy, who is my digital director. Randy, do we have any questions?
Yeah, we've gotten quite a few questions. I hope you can hear me.
Yep.
First, Kayla is asking for Alexis.
Hi, Kayla.
Her 10-year-old. What causes tornadoes?
Well, tornadoes on a very simple scale are caused by a colliding of air masses. Let me go back to my little explainer here. So, a couple of things. You have the warm, moist air coming in out of the Gulf of Mexico, and that can stretch all the way up into the Dakotas. Then you've got the Rocky Mountains out to the west, and guess what is over the Rockies? Lots of snow, lots of dry air, lots of cold lots of cold air, that slides down over the Rockies and down into the Great Plains. Well, now you have a collision of air masses. And you have winds coming in at different directions, right? You've got the cool, dry air coming in from the west. You've got the warm, moist air coming in from the south. And you get a collision of air masses that are perpendicular to each other. And that causes a rotation in the atmosphere. And as these thunderstorms begin to develop, that difference of air movement in the atmosphere causes a rotation. And as these thunderstorms begin to build, that rotation can be lifted up by an updraft, and the thunderstorm begins to rotate, and that rotation can work its way into to the ground and create a tornado. So thunderstorms develop ahead of a dry line and or cold front. You've got the warm, moist air coming out ahead of it, the cool, dry air behind it. The collision of that and the difference in air masses is what can cause thunderstorms. Those thunderstorms can trigger tornadoes.
Okay.
So, Kayla, I hope that answers your question.
Yeah, Sharon wants to know, why is the eye of a hurricane so calm?
Well, the reason why the eye of a hurricane is so strong is because the air is sinking. And you've got a lot of compression going on in the eye. In fact, that's how they are able to determine how strong a hurricane is, by the eye temperature. The warmer the eye is, usually the stronger the hurricane is. So I don't think I have a diagram cross-section of a hurricane. Give me just 1 second. I may have one. So the eye of a hurricane is it's very low pressure at the surface. You have high pressure on top, and that high pressure, the air is sinking inside the eye. So if everything is going down, nothing is going up. And oftentimes in the middle of a hurricane, not only can you see the sunshine and the winds are calm, but sometimes you can even see birds flying that are trapped within the eye, flying along inside the eye, which is really kind of cool. Let me see if I can find this diagram. I hope I'm able to. Drats. I don't. Let me see if real quick, Randy, if I can go back to. So here's a picture of Hurricane Harvey, and it's going to be kind of hard to see on this particular one. But on the outside of the eye, you've got winds that are going up, right? And then as high pressure forms over the hurricane, the winds drop down inside the eye. The eye temperature goes up. As everything is going down, nothing can go up. You have compression in the eye, and that's why it begins to clear out. So it's really difficult to show you on this particular graphic, but the simple answer is the eye is calm because the air is sinking in the inside of the eye, versus the outer ring, which you see where everything is going up. You have a lot of intense thunderstorms that are developing around the eye.
Here's one from Preston.
Hi, Preston.
Wants to know why hurricanes like Ike can have a Category 4 storm surge, but was only a Category 2 storm.
That's a great question. So Preston wants to know why a hurricane like Ike of Category 2 strength can have such a massive surge, that of a Category 4. Well, if we remember Ike developed way out in the eastern Atlantic. Ike came across, let me see if I can change the, Ike came across the island of Cuba and just sort of made a beeline right there for the east end of Galveston. At the last minute, curved up and then went through the Arklatex. So that is generally the path of Hurricane Ike. Ike, if you remember, was a massive, massive hurricane. At one point, the storm took up almost the entirety of the Gulf of Mexico. So there's the eye. So you have this massive hurricane. Now, storm surge is a function of two things. The fetch of the hurricane, basically how long it's been over water, the amount of time that it's been pushing water, and the strength, right? So Ike was a massive hurricane, and it pushed a lot of water at the same time towards the upper Texas coast. What did we just talk about, that concave coast? Look how the coast comes together. You've got this big horseshoe shaped right over Galveston and the upper Texas coast. And that concave coast, pushing this massive amount of water, gets condensed down into a tiny area, and the smaller that area gets, the higher the water got. So even though Ike was not a strong hurricane, it was a huge hurricane, pushing lots and lots of water into a smaller and smaller area. And that smaller area caused the water to rise rapidly. In fact, if you remember, we already had many roads that were closed 24 hours in advance of the eye. Many areas out there towards Galveston, the Bolivar Peninsula, many of the roads, many of the evacuation routes, if you remember correctly, were cut off by the evening of September the 12th. It hit on the September 13th. And many people were trapped down there along the upper Texas coast. So that is the reason why Ike, very unusual to have such a massive surge with such a, quote, weak hurricane. Ike was not weak, but it was only, quote unquote again, Category 2. Now, can you imagine a hurricane the size of Ike that's Category 4 or 5 heading in this direction, and your mind can get pretty out of control pretty quickly of just how catastrophic that would be for our area. Great question, Preston.
Yep. Anna is asking for her daughter Mia.
Hi, Anna and Mia.
When is hurricane season?
I'm sorry?
Mia wants to know when is hurricane season and when is the peak?
Yeah, let's take a look at that. So hurricane season runs from June until November, June 1st until November the 30th. The peak going to be right around September the 10th. And the reason why the peak is so late into the fall, September and October generally are very active, is because the Earth is sort of like a sponge, right? So the longest day of the year is June 21st, the summer solstice, and you would think, well, the most daylight, the sun is the highest overhead, that should be the hottest day of the year. And the reason why it is not is because, well, it takes a while, because the Earth has to absorb that energy. The ground has to absorb that energy day after day after day. And the more energy it absorbs, the hotter it gets. Well, unfortunately, June 21st, the start of summer, is very early into the season as far as the amount of radiation that we're taking in from the sun. So that's why here in Houston, the hottest of the days in August, I call it August, because if you've lived here in August, it is a brutal month. It is very, very hot. And the reason why is because we've absorbed so much radiation from the sun for several months at this point, June, July, heading into August. And it can't really absorb much more. So what happens, it begins to give it back off into the atmosphere, and that's why we see our temperatures 95, 100 degrees just about every single day in the month of August. Well, water, very much the same way. It takes a lot of energy to warm up water. It has a very low heat capacity. So it takes months and months and months of hot temperatures to begin to warm up the waters enough to become conducive for tropical development. And that's why we don't see the peak until September the 10th. So yes, while it can be very hot in June and July, the ground still has more room to absorb that heat and that energy before it begins to give it back. And that usually happens in August and September. The water is often sufficiently warm by that point as well. And that's why we see the peak in the middle of September. Good question. Great question.
We got time for one more question.
Okay.
Christy wants to know what area of the United States gets hurricanes or tornadoes and tornadoes the most.
All right. So what part of the country gets the most hurricanes and the most tornadoes, as in both, as they see the same stretch of coast?
No, different parts of the country. Like where are the hurricanes the most, and where are the worst tornadoes?
Okay, so let's go back to my satellite, and we'll zoom out countrywide here. So the most vulnerable areas for tornadoes are going to be right in this area here. This is Tornado Alley right here. And the reason why is because, remember, we've got the cool air coming in from the Rockies, right? We've got the warm, moist air coming in out of the Gulf of Mexico, and the two air masses are colliding right there over Oklahoma, Kansas, and Nebraska, even into Missouri. Of course, remember a few years ago, Joplin, Missouri, back in 2011, totally wiped out by an EF5 tornado. So anywhere in the heartland is going to be prime time as far as your long-lived, violent, strong tornadoes. We can get tornadoes here along the Gulf Coast. those are more of your maritime waterspouts, EF0, EF1s. And of course, hurricanes, that's going to be generally from the outer banks of the Carolinas through the entire state of Florida and all along the Gulf Coast. Now, Florida has had the most hurricane impacts of any state in the United States, obviously, because they can get hit from 3 different directions. They can come in from the Atlantic. Let me move this out of the way so you can see it a little better. So they can come in from the Atlantic, they can come in from the Gulf of Mexico, and they can come in from the south and hit the Panhandle. They can come in from 3 different directions. So, and their season extends June all the way through November. And you say, well, hurricane season is June to November anyway. But if you recall, I was talking about how the Texas hurricane season is usually pretty limited, with hurricanes mainly hitting this area August and September. And not really many hit here after September. And the reason why is because you have these cold fronts that begin to work their way into southeast Texas, and cold fronts act as a big broom. So when you get a hurricane that might be trying to head towards Houston, this cold front comes in, and guess what? The hurricane gets redirected to the east. So to get a hurricane into southeast Texas after the end of September, exceedingly rare. In fact, off the top of my head, I think it's only happened twice in the last 150 years. So tornadoes, the heartland, we've got the collision of air masses. Florida is going to be prime time for hurricanes, and anywhere that really kind of juts out. The Outer Banks, they get hit quite a bit. The entire state of Florida, and those are really probably the 2 hot spots as far as frequent hurricane activity.
All right. Let's see. Do you have time for one more?
Yeah, let's do it.
Okay. How about Laura wants to know
Hi, Laura.
how hail forms?
I'm sorry?
Laura wants to know how hail is formed.
Oh, hail. Excellent. I believe we're going to be doing a hail explainer in the coming days, but I can give you a quick... Let me see if I can find my hail explainer. Give me just 1 second. I'm starting to get to that point here, Randy, where I need glasses. So I'm starting to squint a little bit here. Okay, here we go. So this is how hail forms. You got a big thunderstorm. Well, in a thunderstorm, you have updrafts and downdrafts, right? So there's your thunderstorm right here. And we'll move forward. There's your updraft. So it's taking everything up into the cloud, raindrops, dust, particulates, and then you've got downdrafts. So a thunderstorm breathes, right? It takes air in and it releases the air. And if you're under that downdraft, this is what we call a microburst, and some of those winds can top 100 miles an hour as they hit the ground and fan out. So a thunderstorm breathes. It takes air in and it takes air out. Well, these raindrops and the dust and all the other particulates in the air can freeze because you have a freeze line in here. So once the raindrops get picked up into the updraft, there go the raindrops, they freeze when they get to the top of the cloud. And just put on a little piece of ice. But as they circulate through the cloud, they get caught in a downdraft, and down they come. And as the ice falls through the cloud, more raindrops stick to that little piece of ice. But wait a minute, whoops, hold on, we got caught in the updraft yet again. So that little piece of ice, which now has other raindrops attached to it, move back into the top of the cloud. Those new raindrops freeze to the little piece of ice, and now our little piece of ice has become bigger. And that cycle continues for several rounds until the updraft itself is not strong enough to support the hailstone, and it falls out through the bottom of the cloud. Of course, here locally, the most common type of hail we see is penny size, pea size. But if you have enough wind shear in the atmosphere and your updrafts are strong enough, you can get hailstones up to the size of grapefruits, softballs. I'm talking this big around. And those are the ones that can do billions of dollars in damage when they fall out under your car or onto your roof. So there's your hailstone. It gets bigger and bigger. The more trips through the cloud it makes. And in fact, next time it hails, if you get, say, like a good golf ball sized piece of hail, pick it up out of the yard, of course, after the thunderstorm passes, and saw that bad boy open, and look at it. And what you're going to notice is that hailstone looks like a tree ring. And each ring represents the amount of one trip through the cloud. So if it has 5 rings, it made 5 trips through the cloud before it fell out the bottom. And that, in general, is how hail forms. Do you have any other, Randy?
Yeah, we've got one more.
Okay.
What is the lowest temperature ever recorded in the Houston area? Do you know that one?
Yes, I do. 5 degrees on January the 20th, 1930. 5 degrees, can you imagine that? Now, we've had 4 instances of single digits in Houston in the last 120 years or so. We had 2 nights. Now think about this. It's impressive, right, to get to 19 in Houston. It's like, wow. We hit the teens, which, by the way, we did in 2017, 19 degrees. Okay, pretty impressive, right? In February 1899, not only did we have a high temperature of 20 in the city of Houston, but the low that night reached 6 degrees, not once, but twice on 2 consecutive nights. Phenomenal. So we had 2 instances of single digits in 1899. We didn't see single digits again until 1930, which was 5 degrees. And then we hit single digits again on December 23rd, 1989. Of course, we all remember that. That was right before Christmas when everybody's pipes froze. And that was one of the most severe freezes we've ever seen in the Houston area. Of course, a quick runner-up would be 1983. We hit 11 degrees on Christmas morning. Of course, another big snow, ice, and pipe bursting event with that one as well. Any others, Randy?
No, I think we've pretty much covered nearly everything. There were a few more questions that came in late, but we can address those offline. I think it was a good session.
Awesome. I hope you guys learned something. This was pretty cool. If you missed anything, go back to Facebook Live or to our Facebook page. The video is still on there and rewatch it. Pretty cool stuff regarding hurricanes, tornadoes, and floods. And, of course, my favorite, snow and ice. So we're going to continue to monitor the forecast here because there is no snow and ice in our forecast. We're talking heat. First 90s on the way later on this week. We've got more of that coming up today beginning on the 411. Have a great afternoon, everybody.